Greetings! NASA is now making very tentative plans to launch Artemis as early as Friday, September 23rd, with a backup opportunity on Tuesday, September 27th. A number of obstacles must be surmounted in quick succession to achieve these dates, however, some technical, some procedural. The dates were chosen to avoid conflicts with the DART mission's Deep Space Network communications requirements and the SpaceX Crew 5 launch attempt. The September 23rd attempt would commence in darkness at 6:47 a.m., and a launch at the opening of the window is not being ruled out. The window duration of 120 minutes has the first 40 minutes in the dark. For September 27th, opening is at 11:37 a.m. in the daylight with a 70-minute window. The first date would be a short duration mission with landing on October 18th. The second is a long duration flight for a landing on November 5th. The biggest unknown is whether Space Force range safety officials will grant the waiver that NASA has now officially requested for the flight termination system. NASA Exploration Systems Associate Administrator Jim Free went out of his way to be deferential to the Space Force. At one point late in the briefing, he even said that comments he made in the last briefing were not appreciated by range officials. Quote, "They felt we were going outside the process," he said. This would suggest some tension between the two organizations. He would not reveal the exact terms of the requested waiver in order, he stated, to be respectful of the range. The first objective is the completion of the disconnect seal repair process, which is now well underway. A very minor notch was noted on the removed 8-inch disconnect seal, and technicians didn't see much on the 4-inch line. Once the umbilical area is buttoned up, attention will turn to a planned fuel loading test, now targeted for Saturday, September 17th, although a delay of a day or two is possible. New software and revised procedures are being developed with the aim of what was called a kinder and gentler loading process that reduces pressure changes on the seals. The scope of the fueling has been expanded since officials last spoke about their plans. Now they will fuel both the core stage and the upper ICPS and are still considering a pre-press test as well. There is no interest, however, in going through a complete wet dress rehearsal that would take the vehicle into terminal count. When asked about the earlier report that operator error in the last count led to overpressurization of the hydrogen lines, possibly instigating the leak, managers tried to walk back the implication that the cryogenic team member made a mistake. Today they blamed inadequate time for trial runs of the manual procedure and said they had apologized to the operator, noting that the whole team was responsible for the switch throw, which apparently was an error. Launch Director Charlie Blackwell Thompson was not present for today's briefing. We wonder if she will address this apparently touchy issue in a future press conference. Here are the highlights of the briefing with more details.
I think there are some things that I probably didn't state clearly enough in the first one. I want to make sure everybody knows that the range has been a great partner in this for us. When we talked after our attempt on Saturday, we were just kind of in the formulation stages of what our plans were. And General Purdy and his team have just been fantastic at listening to where we want to go and giving us their thoughts and us making sure we understand their requirements and concerns. We did submit our waiver package to them to get our retest requirement out there. After meeting with them several times, again, they've been very gracious and understanding of what we're trying to do. I'll reiterate to the fact that our job is to live to their requirements. It is their range. and it's our job to comply with their requirements. So we will do that. Having said that, we're trying to plan a path forward if we're allowed to extend our battery retest requirements on the flight termination system. So to that end, we've asked for a couple dates on the range to support our planning. You'll hear about the tanking test in a few minutes from John Blevins and Mike Bolger. But our requested dates we put on yesterday were the 23rd of September and the 27th of September. Those dates I mentioned on Saturday that we're trying to work with other NASA programs and obviously other users on the range as well. The 23rd we picked. We're trying to deconflict with the DART impact. The conflict there is use of the Deep Space Network. We want to stay outside of their I'll say lockdown of the DSN, which is why we picked the 23rd, so that some of our critical events, if we were fortunate enough to get the waiver from the range and to actually launch on the 23rd, our critical requirements post initial launch would fall on the other side of the impact of DART on the 26th. So that's how we came up with the 23rd. And then the 27th of September keeps us on the right side of DART, or on the back side of DART, I should say, and then in advance of some other activities on the range that are scheduled for the 30th. There's actually no conflict with anything on the 27th. And then we're looking at a third date, but that is a constraint with Crew 5. I mentioned that briefly. We're just trying to work with the Crew 5 program, and obviously Kennedy from a consumables perspective, with other activities on the range with replenishment times for the GN2 between launches.
And working to repair the hydrogen leak that we found during tanking. The repair is basically to remove and replace seals on the 8-inch fill and drain quick disconnect, and then also the 4-inch bleed QD that are both at that flight to ground interface between the LH2 tail service mast umbilical, or TSMU, and the core stage. So to perform that work, we have to demate the LH2 TSMU plate from the flight plate. So there are two plates there that come together, one on the flight side and one on the ground side, to gain access to the QDs. Once the plates are disconnected, the workers install transportation caps in the various lines and a plate cover to protect against contamination while we do the work. We're making great progress. Yesterday we completed the plate demate and began inspection of the seals. Following that, we set up an enclosure around the area to protect the hardware from weather and any other environmental conditions while we perform the seal R&R. Regarding the enclosure, kind of imagine a plastic tent, if you will, that encloses both the workers and the flight plate on some TSMU access stands that we've got out there. So again, kind of imagine a plastic tent, and we've got some conditioned air going in there as well to keep the environment good for the work that we're doing. This morning, we began the R&R. So we've actually got help from our Boeing teammates out there to do that R&R. And if the weather holds up, our plan is to complete both the 8-inch and the 4-inch seal R&Rs by the end of today. Weather could be dicey later in the day, so if that happens, we might just get the 8-inch done. That's something that we'll be keeping a close eye on. Following that, we're looking at a cryo demo for verification of the seal. We set a target date of September 17th. Our timeline to get to that is pretty close, so it could, I would not be surprised to see it slip a day or two, but we're targeting September 17th, and that cryo event will be to verify the seal R&R is good. Our preliminary plan is to have the cryo team tank both the core stage and the upper stage with LH2 and LO2. We're taking a look at our procedures and our software now to think about what exactly that would look like. That could ultimately end up being the long pole to get into the test. One thing that we've talked about with the SLS team, really they brought it forward, is a change in our concept of operations to reduce the pressure and flow changes during tanking. So we're calling it a kinder and gentler approach to tanking. We think that may help reduce the stress of pulses or sudden changes on the seals. So big picture, by replacing the seals and going through this cryo event, making the tanking process as benign as possible, we're optimistic that we can knock this problem flat and have a successful tanking.
First of all, there are FTS batteries that are on each system. So we do have FTS batteries that are on the ICPS. There are FTS batteries on the core stage. There are FTS batteries on the booster. The real heart of the system is the core stage. And so the batteries at question that we're talking about are core stage batteries. They are different than the other systems, and because of their size and mass, they're a little more prone to needing that retest evaluation due to crystal growth. And so ultimately, the batteries that you're really asking about, Bill, are core stage batteries. And so there are three. There's one for every command receiver decoder where you might receive a termination command from the ground and have that set up. And so those actually are kind of the heart of the overall system. And so those are the batteries at question to answer that question there in the core stage. As far as recertify them, I'm really not sure what you're asking, other than we do tests and then we have battery replacement intervals for those tests. But what we do in conjunction with the range or with our partners there is we do end-to-end testing, right? All the components, top to bottom, to verify things. We do also monitor all of the systems while it's on the pad. So there's some monitoring that occurs passively while we're setting out the pad as well. As far as your question on the SRB stack life, we have for a long time, of course, worked with this material, and so there's numerous data that we can use to bring forward to show the risk, which is minimal, with additional stack life based on slump and other properties of the SRBs. And so we continue to do that to show the risk to the decision makers. That risk is very low, and so that's where we are with the SRB stack life.
So let's say, like Mike Serafin said Saturday, we did pressurize the system above the interface requirement that we have from SLS. However, we don't know if that pressure excursion had any effect on the QD. We're still doing that analysis. We know we didn't exceed the hardware design specifications, but we did overpress the system versus that ICD that we've got. So our engineering teams continue to evaluate what happened there. And I talked a little bit earlier about the updated ConOps, about us trying to have a kinder and gentler, if you will, loading process. One of the things that we're really talking about is avoiding pressure excursions. The only other thing I would say is that, after that, our management team apologized to that operator because we had made some manual procedure changes between the attempt on Monday and the attempt on Saturday. So where we normally relied on an automated sequence, we had folks doing some manual procedures, and we practiced it during the week, but they'd only had a couple chances. So we didn't, as a leadership team, put our operators in the best place we could have. We rely really heavily on our cryo team. They really are amazing at what they do. They deliver for us over and over, and I know that they're going to, again, for the next launch attempt.
And I would just add, that's what really we're factoring into getting ready for the tanking test. Charlie Blackwell-Thompson, I keep asking her in meetings, like, hey, let's make sure we have enough time for your folks to be ready and practice the loading procedure. So it's front and center for us. And I said to the team, we all own the process, and Mike just hit on it well. This is all of us, especially us as leaders, and how far and how fast we're pushing the team. So it was as far as I was concerned, everybody's finger was on that switch.
Hey, so there are retest and replace requirements for any of these systems, right? They have a full useful life. The first one we've been talking about is the retest requirement, like when we go back and we evaluate the end-to-end system. There are useful lives of these batteries as well, so there is a replacement life to the batteries. In addition to the retest requirements, we don't bump up against that particular replace requirement within the waiver request. As far as the data, the range is responsible for public safety. And, certainly if we have our sample size of testing, we've got to show confidence beyond that. And that's their call on exactly what that confidence is. I don't want to get into the details of the testing, but we have used similar batteries for much longer than the request. And I say used, I mean tested for longer than the requested time under arduous conditions. But ultimately they have to look at that from a statistical standpoint and make sure they believe the enclosure, the safety is supported with that. But I'll just say the test data shows considerable time beyond the requested waiver for the retest requirements. Once we get to the end of the life of that battery, we replace that battery, and that time isn't just yet. As far as submitting the waiver, we have talked to the range, and part of that is just understanding what they want us to include. There's a lot of things they need to consider. And so there's an initial talk, and we were able to achieve that shortly after the attempt that was scrubbed last Saturday. So I believe Tuesday morning I was in that call with him and several other engineers, and then we submitted the next day all the data that they need to take a look at. And then I think the formal format of that may have come out just this morning. So the last 3 days has been constant contact of working to make sure that we work with them, and we've done that before. This isn't the first time that we work with the range. NASA has a long history of collaborative work with that group in order to achieve flight. So that gives you the timeline. I think that was the last bit of the question, Irene. Certainly, everything on the rocket has some life on it, but when you roll back and forth, and we tend to protect against rolls back and forth, those are complex, and they're kind of fatigue and fracture calculations. It is a very thorough and conservative process. Let me tell you how we got to where we are. What we did is we took originally historic data, right? The first rollout of this vehicle really wasn't so long ago, but you were building it, you were designing it earlier. And so, what you do is you take the information you think you got and you add a little factor to it, and you go analyze that. And so what we did, since we have the same crawler transporter, but we have similar to some other heritage events, we took not just shuttle rolls, but we took empty rolls of the crawler transporter or partial stacks. And, when you add mass to that crawler transporter, you actually attenuate some of that vibration. And so we combined all of that, though, as a spectra, and we give that to the different elements and programs. And then we go in and we try to design the hardware to be certified to a certain number of rolls. Certainly this particular first flight hardware we've asked a little bit more of than we plan on asking out of future flight hardware. But as far as the certification, initial certification was to a certain level that we have not exceeded. We also measured our vehicle rollout when we roll out the first time. I believe it was March 17th. And we had that fully instrumented. And in fact, I had the privilege of walking with the rocket while our loads team was monitoring that info, and we were passing data back and forth to Charlie during that roll, and we hit different speeds. And so that rollout itself was a great test to the system. And so we have that data. The different elements and different parts of the rocket are certified to different levels of rolls. We have not exceeded those, nor will we exceed those if we have to roll back and come back. In addition to that comment, I would like to say, just as far as the process goes, there's not a real known cliff here, right? What you do is you calculate how many rolls that you think you can sustain, if you will, from the critical parts. And then you basically divide that number by 4 so that you can have 4 lives, so that you can have margin to that. And so that's why when we talk about rolls, we want to protect against them, because they are an event. They're a broad event. They affect virtually everything on the rocket. There's other factors that play in, Ken, like for instance, we've got to assume a wind when we roll, right? And so what we assume is that we might be rolling back from even, say, a tropical event. And so we estimate the winds to be in the 47 type knot range at the 60-foot level. And so there's a lot of embedded analysis to cover events, and most of those events have not occurred, and we'd have to go back and do a lot of detailed calculations to give a specific number, if we wanted to, say, clear it for a lot of additional rolls. That would be a lot of work to do that, and it would be constrained by what we assume those events to be, whether those rollbacks are during tropical events or whether there are more benign winds, which is what we've experienced currently today. And certainly those experiences today help add extra life to the vehicle as well. But to answer your question, you asked what would have to be changed. Every element has something different, and it's really about the frequencies at which you roll. And so those do change with the events. And so it'd really be speculative to give you some bolt or some one single component that had to be changed, because if we did go back and we assessed that beyond our certified limit, we'd be looking at the spectra that we have realized and at that time doing the detailed calculations of what we felt was necessary to go in and inspect and either inspect or replace. Let me just add that I do feel confident the vehicle is in good shape, right? And if we need to use rolls, as Mr. Priest said, going back, we're going to use rolls. It's something that as the chief engineer I protect against. Everybody in this call has probably heard me say that, just because it is an event for the vehicle that does add just routine wear and tear, and I don't want to do that. And hopefully, Ken, that answered enough of your question.
I want to be very respectful of what the range, and by talking about it here, even just on Saturday, I think they felt like we were kind of going outside the process, and I don't want to do that. So I really don't want to talk about the total duration that we're looking for, because that is something that is for us to share with them and for them to determine. So throwing that out there, I think would be a process foul for me.
Ariane 5 successfully lofted the Eutelsat Connect VHTS super satellite into its planned geostationary transfer orbit. Here's a slow motion replay of the booster ignition at liftoff. NASA has selected Axiom Space to deliver a moonwalking system for the Artemis 3 moon landing mission. This award, the first one under a competitive spacesuit contract, is for a task order to develop a next-generation Artemis spacesuit and supporting systems, and to demonstrate their use on the lunar surface during Artemis 3. After reviewing proposals from its two eligible spacesuit vendors, NASA selected Axiom Space for the task order, which has a base value of $228.5 million. A future task order will be competed for recurring spacesuit services to support subsequent Artemis landing missions. Axiom and NASA have released no details of the suit design or even a complete rendering of a mock-up. As analysts have expected for months, Apple announced an upcoming satellite connectivity function. The feature is limited to emergency SOS text messages and is only available on the new iPhone 14 models, which will have a special antenna which must be pointed at the Global Star satellite within view. The tool is free for 2 years with an iPhone 14 purchase. It is far less ambitious than the text service planned for Starlink satellites on the T-Mobile network, or the broadband system being developed by AST SpaceMobile. Continued competition and technology development should provide consumers with radically improved systems in the coming years. Our fantastic Mars helicopter, Ingenuity, has flown again. It completed its 31st flight, lasting 55.6 seconds, flying 318 feet at a maximum altitude of 33 feet and a ground speed of 10.6 miles per hour. The sturdy flyer has now logged an incredible 57 minutes of flight time for a distance of almost 24,000 feet, almost 4.5 miles. For your Friday, it's National Teddy Bear Day. So why don't you hug a bear and enjoy life? And that's the way space is today. Until tomorrow, add in Explorata toward the unknown in the measureless arena of space. Stay tough and competent, and thanks very much for watching.
Wall Street was slightly higher on Thursday, with gains of about 0.5%. 15 of our space stocks were up, led by Aerojet Rocketdyne and Terran Orbital. The biggest losers were AST SpaceMobile, still suffering from the Apple satellite phone announcement, and Planet Labs. Reporting from cyberspace, this is correspondent Karen Calvis.